Okay, so for this question 7, we can see this is our situation. The table shows the quantity in kilograms and the amount of 3 types of fruits brought by 3 stores at night market. Okay, so this is your store and then different fruits here and how much they paid. So they say the price per kilogram for mango, durian are XYZ. So they're denoted for you. What's your X? X is about mango, Y is about durian, Z is about rambutan. So this is the price that you need to pay for per kg. So form the system linear equation. So form the equation first and then to represent the total expenditure per store. So calculate the weight and write the system in metric. So these 3 marks at the beginning here is ask us to form our equation, linear equation and our metric form equations. So you can see for the store P, so they will need to use 5 kg X and then 3Y plus 2Z equals to their payment is 34 ringgit. So second store is 3X, 4Y, 4Z, 37 ringgit. And then 2X, 3Y, and then 4Z, 29 ringgit. So this is our system linear equation. Then they ask us to put in metric equation. So our coefficient, this is our coefficient metric, this is our unknown metric, this is our answer metric. So our coefficient metric, nombor-nombor di depan sini, iaitu 532, then 344, and then 234. So in the middle here is unknown metric. Unknown, what is our unknown? X, Y, Z. And then the last here will be our answer, will be 34, 37, 29. Okay, so this is how we build out our equation. Okay, so this is our 3 marks here. So when you get these 2 equations correctly, we get 1 mark. Everything correct, we give you another marks. And your metric form is 1 marks. So from here, the question already denoted for us. They're denoted for us in metric forms. In metric form, this is what we call metric A. This is what we call metric X. This is what we call metric B. Okay, so therefore, when you want to do the question B, they say find the determinant minor adjoint metric A. So we will refer to this. We are going to use this metric A. We are going to find the determinant, find all the minor and adjoint. So for metric A, the determinant of metric A, I will do the determinant by expanding first row. So first row is A11 minus 11 minus A12 minus 12, A13 minus 13. So their minor, how to do their minor? We will cross over 1, 1, row 1, column 1. So we will get 4, 4, 3, 4. Then we copy and paste 4, 4 here for entire row. And then in out 4, 3. Then we see the vertical. When we close here, the vertical here is 3, 3, 2. 3, 2. So now we're going to proceed to do the determinant 2 by 2. AD minus BC, AD minus BC, AD minus BC for here. So this is our determinant. Then we cannot try to skip to core factor, yeah, because the question asks us to find minor first. So actually, when we want to find adjoint, what is our concept? Our adjoint matrix A is going to find cofactor transpose. So most of the time I will skip to find cofactor, then do the transpose, I will get adjoint because question asks me to find adjoint. But for these questions, they ask us to find minor first. Okay, so as we revise here, adjoint is finding cofactor and transpose. Cofactor is finding plus or minus for minor. So minus is what? Minus is going to cancel. Cancel in your position. If you 1 1, row 1, column 1. If you 2 1 means row 2, column 1. So that will be our minor. So minor is eliminating row and column. Cofactor is in your position, which is positive, negative, time with the minor. So means cofactor got positive, negative. And then for adjoint, you will be taking the cofactor and transpose its position. So it becomes transpose. So now I'm going to find out what is our minor. So for this minor, I'm going to do a big bracket because I have 9 position here. 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, then 3 1, 3 2, 3 3. So I have 9 minor here. So this is minor 1 1, this is minor 1 2, this is minor 1 3. This is minor 2 1, minor 2 2, minor 2 3. This is minor 3 1, 3 2, and 3 3. So no positive negative because I'm not doing cofactor. Cofactor only have positive negative according to their position. So we start again our minor 1 1. Close your row 1. Okay, close your row 1, column 1. So 4 4, 3 4. So my method I can do it for entire row faster. So 3 2. Okay, now I'm going for 2 1. So when I close 2 1, I will get 3 2, 3 4. So copy paste in out. So what is vertical things? So when you close it, you can see those vertical things is 5 2. Okay, of course I don't want to effect my answer here. I have to rub off here. Then 3 1, I'm going to close row 3, column 1. So it will be 3 2, 4 4. So copy paste in out. Those vertical is 5 3. Okay, so we simplify it. What's the answer? So simplify it by doing AD minus BC. So AD minus BC, all of this. So this you're getting 4. This one, 12 minus 8, 4. This one, 9 minus 8, 1. This one, 12 minus 6, we get 6. And then this one, 20 minus 4, we get 16. This one, 15 minus 6, we get 9. And then this one, 12 minus 8, we get 4. And then this one, 20 minus 6, we get 14. This one, 20 minus 9, we get 11. So this is our minor matrix. Okay, so we done our determinant, we done our minor. Now I want to proceed for adjoint. So for adjoint, I need to find what is cofactor first. So cofactor will be positive, negative, minor. So since I get my minor already, I can refer here in the position, positive, negative, positive. So positive, negative, positive, then continue negative, positive, negative, then positive, negative, positive. So that will be my cofactor. Then lastly, I can get my adjoint. So which is cofactor transpose. Transpose means we are going to change the position, row become column. So 4, negative 4, 1. Second row, -6, 16, -9 become column. Then third row, 4, -14 become third column. Okay, so we're done for this adjoint. We see how we're going to mark this. What is important concept here? So first of all, they ask us to find determinant. So of course, our concept of determinant and the answer. Then they ask us to find minor. So we are going to see how you eliminate your row and column for this 9 position here. And then get to the answer. Then lastly, we see what's your concept of adjoint, which is cofactor transpose. Okay, so this is how we see your cofactor and transpose. Finally, this is your adjoint, so 6 marks. Then we continue for question C. So they said, question C, based on part B, find our A inverse based on part B. Part B, what we have done here is determinant and adjoint. So means that at here, when you want to find A inverse, we are using adjoint method. Okay, so adjoint method will be 1 over determinant A times adjoint A, where our determinant just now is 10 adjoint. So we put in our adjoint answer. So remember, we have to multiply in our 1 over 10 and simplify. This one, we hence means using this A inverse, we're going to solve the matrix. So just now they give us the matrix equation is AX equals to B. So in order to get our unknown matrix there, we want to solve our X, Y, Z. We will type in A inverse in front of the matrix. So it will become identity A inverse with A. Then identity with X, will I get back X matrix. So our unknown matrix X, Y, Z. What is our X matrix? Our unknown matrix X, Y, Z can be obtained by finding A inverse times our matrix B. So we substitute our A inverse here. Then B matrix, I have to refer back to the question A just now. B matrix is the ringgit, 34 ringgit, 37 ringgit, and 29 ringgit. So means that X is the kilo for mango, 3 ringgit per kilo. Y is for Durian, 5 ringgit per kilo. And then Z is for Rambutan. There will be 2 ringgit per kilo. So this is how we solve. Okay, so this is how we find our inverse matrix using adjoint method and its answer. And finally, our concept of finding X, Y, Z and answer. So don't forget, put your answer, take out your answer. What is X? What's your Y? What's your Z? So questions D, they say, supposedly for the price per kilogram for mango, durian, and rambutan has increased. So means their price have increased by 2 to 1 respectively. we have to form a new metric that represents this amount spent for each type of the fruit. So originally, what is our metric? What's our metric? So we can look at our kilogram there. For store P is 5 kilo, 3 kilo, and then 2 kilo. For store Q is 3 kilo, 4 kilo, and 4 kilo. And store R will be 2, 3, 4. So for the price here, XYZ is for our price per kilo. They say increase 2 to 1. So originally is 3 ringgit, so increase 2 become 5. So this increase 2 becomes 7. This increase 1 ringgit become 1, become 3. So their price here, the latest price here is 5 ringgit, 7 ringgit, and 3 ringgit. So obtain this new metric. So what's the expenditure here? So we will do the multiplication row by column. So it will be 25 plus 21 plus 6, 52. Continue for the second store, 55, and then 43. Okay, so this is how we write our new system of metric equation after increasing the price and its answer, the expenditure for each store.